Welcome to Smiley Geo, where I teach you how you can build GIS tools, and if you're afraid of AI taking your job, I will also teach you how to use that. We're going to make a Python tool boilerplate for a geoprocessing tool in ArcGIS Pro. And please like, share, and subscribe. Let me know if you have any other ideas for tools or videos that you want me to make. I will probably keep putting out a video every 2 or 3 weeks. It won't be that often because it is the summertime and a lot of outdoor stuff going on. But if you like these, I'll keep on doing them. We're going to get started. I have my code editor open. I'm using a tool called Cursor. You can go to Cursor's website and download it. In order to use ArcGIS Pro tools, you want to make sure in the bottom right corner it's pointing to the ArcGIS Pro Pi 3 Python environment. I may go into that in another video, but you can go find that by clicking on that and then enter the interpreter path, and it will let you browse into your program files where you can find it. And that is going to be at program files all the way down to environments, and then you'll find the Python executable, and you can add that to your code editor. And whenever you make a Python tool, this is called a .py file. It's good to make a section at the top where you describe what your tool is, who created it, what does it do, versions. These are comments if you're new to programming. Anything with a hashtag is something that does not get executed with the program. I can write helpful comments behind the help hashtag to help me know or help someone else know what the code is used for and what it does. So the first thing you want to do when you're creating a Python boilerplate that you can reuse is import ArcPy. ArcPy is the default geoprocessing library that includes tools like export features, feature to feature, this clip tool, anything that you would probably be using in ArcGIS Pro. And it has a whole bunch of other functionality that you can use when writing scripting tools and workflows. Then I'm going to make a comment called set parameters. I'm going to turn off my autocomplete so it's not in the way. And I'm going to set 3 parameters that the tool is going to use to do the clipping. And this is going to be basically a copy of the clip tool that's already in the analysis toolbox. So I'm going to call my first user input parameter input features. And what I'm doing here is I'm creating a variable, and that variable is going to store something. In this case, it's going to be whatever the user puts into the tool, and it's going to store that as a text. And we're going to use ArcPy to call that. And you write it with ArcPy dot, and then it should start pulling up some options for you. And this will help you narrow it down. And then we want get parameter as text. And in Python, your first item of anything is going to start at 0. So I'm going to put parentheses here and then put a 0 in the index, and that means that's going to be my first parameter. And then we will do 2 more. Of course, we need clip features. That's going to be the boundary that we use to clip something. And that's going to be my second parameter. And then we need the out features, which is going to be an output, and that's going to be the folder path to a geodatabase that your results get stored in, and that's going to be a feature class. And then something I like to do is put a helpful comment about the data type. So in this case, it's going to be a feature class for each one. You could also do feature layer. So a feature layer would let you drag and drop something on your map. Feature class lets you browse to and select feature class from a geodatabase. So this can be several things, but we're going to leave it as a feature class today. And those are my output, those are my parameters for my tool. And then the next thing I want to do is create the main logic for the tool. And this could also be called core logic, but this is going to be the block of code that executes all of your processes, in this case, the clipping. And this is a pretty simple tool, so all I'm going to do is use ArcGIS to call the clip tool. That's going to be in the analysis toolbox. So first I call ArcGIS, which is the tool library, and then dot, and then that's going to let me call the toolbox, which is analysis, and then I'm going to use the clip tool, and then open parentheses. And then when you open parentheses, you can see that it gives you a tooltip, which is helpful if you want to know the order of how things need to go in the parentheses. And then you can add things which are called arguments, and these are going to be your input parameters. So you can see the order I need to enter it is in features, and then clip features, and then output features. These are named slightly different, but it's just providing a template basically. There's a few other knobs and things we can tweak here. None of that is important right now. So all you need to know is what is the order that you need to write your parameters in the parentheses. So in features is the first one, and then the clip features, and then we have the out features. So that is going to execute the clip tool with the parameters that the user enters. And another helpful thing that I like to do when creating scripting tools is write messaging. The messaging comes from ArcGIS, and it can help you troubleshoot or debug a tool if something goes wrong. And it can show messages to the users so that they're not left in the dark just watching something spin forever. They can actually see what the tool is doing in real time, and that will help them know when it's going to be done. So you do that with ArcGIS, and then something called add message. And then in the parentheses, I can put whatever message I want. In this case, we're going to put quotes to represent a text string. And I'm going to say that this is clipping features, so the user knows what processes are going on. And then at the end, I will add one more message, and that's going to let the user know when it's done. And we're going to say it's clipped, and the output is saved to. A helpful trick for me is if you want to add whatever the output folder path is that gets stored to out features, just go down here and add a plus sign, and then copy your parameter here. And that's going to tell the tool, hey, the tool is done, here's the message, and then it's saved to whatever this output features path is, and that's going to print that on screen for you, so you can easily copy that if you want to know the location. So that is the core logic of the tool. It's going to take those three parameters and then put them in the clip tool and output results. And one thing that you need to do if you're using scripting tools is you need to wrap all of this into a function. I won't go into detail about what a function is today, but all you need to know is a function keeps you from having to write things over and over again, and it keeps your code modular so that you can reuse the functions over and over, and this results in you having to change less over time and keeps your code clear and more maintainable, especially when you're sharing it for others to see. So I'm going to write define clip tool. Define is a declarative statement for me to say what the name of the tool is, and I'm going to call it clip tool. This function can be any name that you want, and then put a colon. Whenever you define a function, everything that's underneath the function needs to be indented. And so it gets indented 4 spaces automatically in the code editor. But if you're doing this in Notepad or something, just know that it needs to be indented 4 spaces here. And then we will do something called if name equals main. Which is saying if name is identical to, the 2 equal signs is identical to. And what this line is saying is you don't need to worry too much about it right now, but that is essentially calling main, which is the default program that's going to run the function. And all of that is kind of happening behind the scenes, but this is the way that you can call your function, which is clip tool. And then I'm going to write the name of the function to call. And there you go. So this tool is going to import the ArcPy library, and then it's going to call this function, and it's going to do everything in the function, which is accept whatever parameters the user puts, and then it's going to clip those and give you an output. So now I can go ahead and save this and go into ArcGIS Pro. So I'm in ArcGIS Pro now in my APRX project, and I have an interstates layer and a county layer. And what I want to do is go ahead and run my tool. But before I do that, I'm going to show you how it gets created. So I have a tool here called My Clip Tool that I already created. And the way you create a tool is by right-clicking on the toolbox, going to New, and then clicking the blue scroll Script, and that will let you create a tool that you can wire up to your .py file that you just made, and that's how you can call these tools in ArcGIS Pro. If I right-click my tool that I made and go into the properties, you'll see that I have already set up and configured the parameters that I mentioned earlier. You will see the names of those parameters. These need to match closely with what's in your script. And then also the index 0, 1, and 2. If I go back to my script, you'll remember these are 0, 1, and 2. So those are matching up well, and you will also want to pay attention to the data type. I am currently having the user put in a feature class. However, you can also do a feature layer or a host of other different data types, and you can experiment with those as you make these tools. We have 2 inputs, which is mimicking the ArcGIS Pro native clip tool, and then the output is going to be the results of that clip, and that's going to a feature class. If you go down to the execution pane, you'll see that there's a button where you can browse to and connect your script. So let's go there to my scripts folder and use the arcprotool.py script. So I will select that. It will appear in the text box below, and then I can hit OK. And then after that is selected, you'll see the code that I just wrote. I can click OK. And we won't worry about the other properties for today. We will just run the tool and make sure that it works. So if I double click the tool and open it, you can see the 3 parameters. I'm going to browse to each one. I want to click the interstates to the county. And then I'm going to browse to and write a name for the output feature class. That's called clip result. Click OK. Once these are all filled in, I will run my tool. And if you click view details, you can see that those 2 messages are outputting so the user can see what the tool is doing, and they can also see the path where the output gets made. And then you can see on my map the output is this green line, and if I turn off the interstates, the clip result is only getting clipped to the county boundary, so we know that it worked. So now I have Cursor back open in a different folder, and I'm going to see if Cursor can create the same kind of Python boilerplate using a prompt. It will create its own Python file. So let's see if we can get it to recreate it and how good it can do. So I want to build or create a simple Python boilerplate for a clip tool that will be used in ArcGIS Pro. And I'm currently using Claude's Sonnet model medium. If I use maybe Fable or Opus, it might have a different output, but let's see what happens with that. So Cursor finished creating the tool. It created a cliptool.py file in this folder directory. It gave me all of the details on what it did, and in green you can see the changes here, and we're going to see if this tool works by connecting it to a tool in ArcGIS Pro. If I hit keep and then I save this, I can go back to ArcGIS Pro, and I will go into this cliptool.ai and resource my file to scripts AI version of that, and I'm going to click that, click OK. I can see that it's now pointing to my AI version of the tool, and then if I double click this, should be able to choose the interstates again. So let's see what this does. View details, and we can see, oh, the string object is not callable. So I found the error, and what ended up happening was we had our function name as clip features, and I simplified some of this logic by removing the default values. We had it like this with clip features as the function name. We had that as a parameter, and it was giving me an error called string not callable, which means that it cannot pass both the function name and this parameter name as the same thing. So we got to change one of them. So I changed the name of my function to clip tool, and then I go down here and change where in the line where I call that, and then that will successfully execute the tool if you run it again. So that's one of the quirks of AI, is that it can mess up. You want to have some basic fundamentals with Python or whatever language you're using to be able to identify those errors. But all in all, it can create a good boilerplate. The best way to do it would probably be to create a boilerplate from scratch and then use AI to extend the tool. Thanks for watching. If you have coordinates that you would like to convert between decimal degrees and degrees, minutes, seconds, check out my app, chordlyapp.com. I can link that in the description. It will have a paywall if you use an Excel file or CSV more than 30 rows, but you can get around that by splitting it up. It is a convenience feature, and I will be adding more GIS functionality soon. Let me know what you think. Happy 4th of July.